we now discuss the solution of a problem on scalar triple products from the vector algebra. This question has appeared in joint entrance examination main held on 27th July 2021 in the second shift. The problem is, let the vector A is equal to I minus alpha j plus beta k. The vector B is equal to 3i plus beta j minus alpha k, and vector C is equal to minus alpha I minus 2j plus k, where alpha and beta are integers. If the vector A dot the vector B is equal to minus 1 and the vector B dot the vector C is equal to 10, then A cross B in brackets dot C is equal to, in brackets, the vector A cross the vector B dot C. So you are given three vectors A, B, C, in which these alpha, beta are appearing and they are integers, and you are given A dot B is minus 1 and B dot C is 10, and required to find A cross B in brackets dot C is equal to. Now this is our given problem, right? So let's now discuss the solution of the problem in detail. Solution. Given the vector A, I is equal to I minus alpha j plus beta k, the vector B is equal to 3i plus beta j minus alpha k, and the vector C is equal to minus alpha I minus 2j plus k, where alpha and beta are integers. You are given A dot B is equal to minus 1. So the vector A dot B is equal to minus 1 will imply the vector A is I minus alpha j plus beta k dot the vector B is 3i plus beta j minus alpha k is equal to minus 1. So take the dot product. It is 1 into 3 minus alpha into beta minus alpha beta plus beta into minus alpha, that is minus beta alpha is equal to minus 1. That is 3 minus alpha beta minus beta alpha is equal to minus 1. And this will give you 2 times alpha beta is equal to 4. Therefore, alpha beta is equal to 2. Let's call this as the equation 1. And we are further given B dot C is equal to 10. And B dot C is equal to 10. That will imply B, the vector B is written here, dot vector C is taken here, and that is equal to 10. And take the dot product, 3 times minus alpha, minus 3 alpha, minus 2 beta, minus alpha is equal to 10. And minus 3 alpha, minus 2 beta, minus alpha is equal to 10. And that will be 3 alpha plus alpha 4 alpha plus 2 beta is equal to minus 10. Minus 10. And cancel off 2 on both sides. You will get 2 alpha plus beta is equal to minus 5. That is the equation 2. Since alpha beta belongs to Z, let us take the equation 1, that is alpha beta is equal to 2, and we know, and alpha beta are integers. Then we get alpha is equal to 1, beta is equal to 2. So that may be possible. Or alpha is minus 1, beta is minus 2. Yes. Or alpha is 2, beta is 1. Right. Or alpha is equal to minus 2, beta is equal to minus 1. So these are the possible values of alpha beta, because alpha beta are integers and alpha beta is equal to 2. Agreed. And let's look at the equation 2 and which of these combinations of alpha beta satisfy this equation. So if you take alpha is equal to 1, beta is equal to 2, it will be 2 times 1, 2, plus beta is 2, 2 plus 2, 4, 4 is equal to minus 5. This does not satisfy. And you observe that alpha is equal to minus 2, beta is equal to minus 5 satisfies this equation. Alpha is equal to minus 2, that is 2 into minus 2, minus 4, minus 1, beta is minus 1, that is minus 5. That will satisfy that equation. So notice that alpha is equal to minus 2 and beta is equal to minus 1 satisfies the equation 2. Therefore, alpha is equal to minus 2, beta is equal to minus 1 are the solutions of these equations 1 and 2. Take these values of alpha and beta, substitute in A, B, C, then we get A is equal to I plus 2j plus minus k, B is equal to 3i minus j plus 2k, correct? And C is equal to 2i because alpha is minus 2, so 2i minus 2j plus k. Now we are ready to compute A cross B in brackets dot C. We do it in the next slide. We have these three vectors. This is the brought forward from the last slide, and required to find A cross B in brackets dot C. And A cross B dot C is same as C dot A cross B because the dot product is commutative. And C dot A cross B is the scalar triple product of the vectors CAB in this order. CAB in this order. And the scalar triple product of CAB in this order is the 3 by 3 determinant whose first row are the entries which are the components of C, second row that of the components of A, and third row that of the components of B. So that will be equal to, so C components are 2, minus 2, 1, A components are 1, 2, minus 1, and that of B will be 3, minus 1, 2. Let's now expand this by means of the first row. That will be 2 into 2 2s are 4, minus 1, minus minus plus plus 2 into 2 plus 3 plus 1 into minus 1 minus 6. And this is 2 into 3, 6, plus 2 into 5, 10, minus 7. So that is the one. 6 plus 10, 16 minus 7, that is equal to 9. And our answer is A cross B in brackets dot C is equal to 9. That's our answer. And that is the discussion of the solution of the problem on scalar triple product of vectors from vector algebra. I am sure that you have understood the solution of this problem, and go on working out some more problems from the vector calculus. And I wish you all the best. Thank you.